Okay. So today we're looking at section 2.1, rectangular coordinates and graphs. Now the rectangular coordinate system, also known as the Cartesian coordinate system, consists of an x and a y axis, which are perpendicular to each other. The point at which they meet is known as the origin, denoted 0, 0. And the four areas created by these axes are known as quadrants, labeled counterclockwise, quadrant 1, 2, 3, and 4. Each point on the plane can be written as an ordered pair x, y. And the x-coordinate is the horizontal distance from the origin, and the y-coordinate is the vertical distance from the origin. So let's plot these points here. Start with 2, 6. That means 2 on the x, 6 on the y, and where they meet, that is our point. 2, 6. And we have 5, negative 4. So we go 5 positive on the horizontal axis and 4 negative on the vertical axis. Right there. 5, negative 4. Then we have negative 1 and negative 8. Which is right there. Negative 1, negative 8. And then we have 0 on the x-axis and 7 on the y, which is right here. 0, 7. And that's the basis for how this stuff is set up. So, one of the ways that we can help ourselves when graphing is finding the x-intercept and a y-intercept. To find the x-intercept, you let y equal 0 and solve for x. We have a point x0. That'll be your x-intercept, because it intersects the x-axis when y is equal to 0. Likewise, the y-axis or y-intercept, you let x equal 0, solve for y, and you have a point 0, y. That'll be your y-intercept. So we're going to find the x and y-intercepts for this particular equation. So to find the x-intercept, we let y equal 0. 0 equals negative 2x plus 6. Subtract 6 from both sides. Divide by negative 2. X equals 3. Y equals 0. 3, 0. To find the y-intercept, we said x equals 0. So y equals negative 2 times 0 plus 6, which is simply y equals 6. So the y-intercept here would be 0 on the x-axis and 6 on the y. Let's look at another one here. Okay, again, same principle. Find the y-intercept by letting x equal 0. 8 times 0 plus 7y equals 56. So 7y equals 56. Y equals 8. So 0, 8 is our y-intercept. To find the x-intercept, we set y equals 0. So I have 8x plus 7 times 0 equals 56. 8x equals 56. So x equals 7. So 7, 0 is my x-intercept. Now what we're looking at here is linear equations. So another method we can do this is we can determine some other points. Always determine other points on the graph by either plugging in x or y and solving for the other. Find the missing point, negative 2, whatever, that lies on the graph of y equals negative 3x plus 11. So what that means is let x equal negative 2 and find what y is. Well, negative 3 times negative 2 is 6 plus 11 gives me 17. So that point on that graph is negative 2, 17. Okay, here we just want to complete the ordered pair so that the solutions to the given equation, and then we're going to graph it. So we're going to find y for all these different values of x. So y equals 3 times negative 2 minus 1, negative 6 minus 1, negative 7. Y equals 3 times negative 1 minus 1, negative 3 minus 1, negative 4. Y equals 3 times 0 minus 1. Y equals negative 1. We have y equals 3 times 1 minus 1. 3 minus 1, which is 2. And then y equals 3 times 2 minus 1. 6 minus 1, which is 5. So now we have 5 points. Let's plot our points. Negative 2, negative 7, negative 1, negative 4, 0, negative 1, 1, 2, and 2, 5. Then we draw our line. And that, we just graphed our first line. Okay, so we have some interesting things that we can do on a graph. Relationships between 2 points. There's 2 in particular we're going to look at. So when given 2 points on a graph, we can determine the distance between the 2 points as well as the midpoint between the 2 points. We're given the distance between 2 points, x1, y1, and x2, y2 is given by d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. The midpoint for 2 points, likewise, is x1 plus x2 over 2 and y1 plus y2 over 2. So find the distance and the midpoint between the points 2, 1, and 3, 5. Verify by plotting the points on the graph. So I have 2, 1. I have 3, 5. So this is the distance I'm looking for. Now, it doesn't matter which one we consider x1, y1, and x2, y2, as long as we're consistent. So rolling up a little bit here. So our distance equals the square root x2 minus x1 squared plus y2 minus y1 squared. Now, excuse me, a trick to this, since we're subtracting, to avoid having negatives, not that it matters, but if one point, both coordinates are higher than the coordinates of the other one, let this be x1 or x2, y2, and this be x1, y1. Again, it doesn't matter which is which. So we're looking at the square root of x2, which is 3, minus x1, which is 2, squared, plus y2, which is 5, minus y1, which is 1, squared. So this is simply the square root of 1 squared, which is 1, plus the square root of 4 squared, which is 16, gives me the square root of 17. Now to find the midpoint, we take x1 plus x2 over 2. Oops. x1 plus x2 over 2, y1 plus y2 over 2. Again, it don't matter which is which as long as you're consistent. And since it's plus, it doesn't really matter even then. So we have 2 plus 3 over 2 and 1 plus 5 over 2 gives me 5 halves and 3. For the point P equals -5, 6, and Q equals 2, -2, find the distance from P to Q and the coordinates of the midpoint. So again, our distance is the square root x2 minus x1 squared plus y2 minus y1 squared. So doesn't really matter here. Let's go ahead and let this be x2, y2. I have 2 minus a -5 squared plus -2 minus 6 squared gives me 7 squared plus 8 squared, which is 49 plus 64, which is 113. Frequently, these don't come out as pretty as we'd like. Now to find the midpoint, again, it's x1 plus x2 over 2, y1 plus y2 over 2. So we have -5 plus 2 over 2 and 6 plus -2 over 2. This is -3 halves, and this becomes simply 2. That is our midpoint. And that is all for this particular section. I will see you next time.